Our next chapter is on functions. So, in this chapter, we're going to learn how to construct a program with more than one function. So far, the programs we have seen contained only one function called main, and in this chapter, we're going to see programs which contain one main function, and all programs are supposed to have only one main function. And then the main function itself can call or can use other functions in order to obtain a desired result. So the different things that we're going to learn of course, are what is a function declaration? What is a function call? How do you define a function? And then in general, what is involved in a function design. And then if you have a function using another function, how do these functions communicate with each other? And in the context of using functions, there may be things that are available to all functions within a program, and there may be items which are local only to one function. So we need to understand what a global and local scope for different items used in the function are. And finally, we'll end the chapter with some tips from software engineering. So we're going to look at a function type among a number of different what we call derived types. Derived types are those which are obtained by combining the primitive data types that we discussed so far in this course. And the earliest of those is the functions. That's why we are covering them here in chapter 4. And we'll be looking at array and pointer types in chapters 8 and 9. And we may be looking at a basic definition of structure, and we're going to stop with that. We'll not look at union or enumerator type. So, as far as our purposes of this chapter is concerned, we're going to start talking about writing a program for solving a problem. And then in order to find a solution to the problem we want to solve using the computer program, we want to subdivide the problem into smaller problems and construct maybe small programs for solving each of the subproblems that we identified. Then we need to combine these to find out or to come up with a solution of the actual problem that we originally started out with. And the functions, I'm sorry, the partial solutions or the solutions of each subproblem that we construct this way are called modules, and each module is going to be a function. So as far as we're concerned, we have a main function that can use other functions, and then each of the other functions can use other subfunctions as well. And this way we keep breaking up problem into subproblems and subproblems into subproblems, etc., until we reach a point where the solution to this subproblem we identified no longer needs to be subdivided into solutions for subproblems. One of the things that we're going to finally show in this is what is called the top-down design. And what that means is, as we said before, the main function is where the execution is going to start, and that's called the top of the solution process. And then we're going to keep subdividing that into smaller parts. And of course, each of those modules is going to be called a function. So here is a picture that represents the relationship among different functions used to solve a problem, an abstract problem here. We're not defining any specific ones. Okay, so let's say the main function is the one that is where you're constructing the solution to the entire problem inside of the main. So there you're going to be referring to, okay, in order to solve this problem, let me first solve module 1, then solve module 2, then solve module 3, somehow combine them. Then when you're solving module 1, you can say, okay, this problem can be divided into module 1A, module 1B, and module 1C. Module 2 has a subproblem which is called module 2A, so it's got only one subproblem. Module 3 is going to have module 3A and module 3B, which is two subproblems. So a diagram which shows this type of relationship between the different modules is called a structure chart. As you can see, we're not defining any problem here, any solution here. We're only showing the relationship between the different parts in a solution process for a big problem. So this is all things that we've already learned, but the second paragraph here is important as well. Unlike a mathematical function, a computer function or a function in a computer program, okay, can not just calculate something, or maybe don't even have to do any calculation at all, but it could perform an action. For example, when we did the greeting program, which was just printing out a message, okay, we did not do any calculation. We did not take any data in. We did not return any data, okay, but we did something that we wanted as an action. That action, where there is no data transfer or data manipulation involved, is a side effect, for example. So a function can take no data, maybe, or some data, and it can return no data or at most one data, okay? Or it could have all of those things and have a side effect, or none of these things and have a side effect. So that's what is described in this. So we already talked about this. Go on. So here is another picture, which is the same as what we call module 1, module 2, module 3 before. And each of those modules had submodules there. And now we're calling them functions. Okay, and then we are calling the submodules as the ones called by immediately preceding module. For example, function 1, function 2, function 3 are called by main, whereas function A, function B, function C are called by function 1, function D is called by function 2, function E and function F are called by function 3. Again, this one shows the relationship between functions, no details. This picture is called a structured diagram as well. So this is kind of another picture that is showing you how we described the function before. So if you look at a function as a box, it's going to be supplied with input data, maybe no input data, maybe some, 0 or more data values. They're going to be supplied or passed to this box. And the box, inside of the box, all the instructions that you want to give the computer to perform calculations or the actions, okay, are going to be described. And that's called a function definition. And the actions, which need not have any data impact, okay, are called side effects, or they may have data impact. That is not necessarily communicated in terms of the actual data that's being passed or actual data that's being returned. It's called a side effect, and we may want that. And then finally, we return at most one data. So maybe you return nothing or you return one. That is what the characteristic of a function is.